Hi guys, my name is Võ Anh Tu. I am a chemistry teacher at Quốc học Huế High School for the Gifted. This is my e-learning lesson prepared for grade 11 students. Hope you enjoy it. Welcome to our chemistry class. Today, we are going to discover the world of nitric acid, its chemical properties, as well as its uses and how we can prepare this interesting chemical. Here's the glimpse to what we're going to go through: its physical properties, its chemical properties, as well as its application and how we can prepare nitric acid. First off, physical properties. What is the state, the color, the smell, the boiling point and melting point of this acid? Keep these questions in mind as we are going to uncover the answers. Make a guess. Which of these three bottles contain nitric acid? If your answer is any of them, you are always correct, because all three of them contain nitric acid. Why? Nitric acid is usually kept in a dark brown bottle. The second bottle contains the same liquid when it is in use. Pure nitric acid is a colorless fuming liquid with a pungent odor. There are different concentrations of nitric acid available. They are colorless, yellow, or red. The industrial grade is about 68% in water. Pure nitric acid is not very stable. It decomposes into water, nitrogen dioxide, and oxygen in the presence of sunlight, forming a brownish yellow solution due to the reddish brown of nitrogen dioxide. We can observe this in the third bottle. Other physical properties can be seen in this slide. It is completely soluble in water. Pure acid has a density of 1.45 gram per milliliters. Nitric acid boils at 86 degrees Celsius and freezes to a white solid at -42 degrees Celsius. It has a corrosive action on the skin and causes yellow blisters. Do you know why the acid rain is bad for the environment? Do you know how people purify gold? By looking at the chemical properties of nitric acid, we will be able to unveil the answers of these questions. Always, when we look at the chemical properties of any substance, we first look at its chemical structure. The nitric acid molecule is planar with the nitrogen attached to 3 oxygen atoms, one of which holds the proton. This displays the acidity of this acid. Furthermore, the oxidation state of nitrogen atom is the highest at +5. This hence displays the oxidation property. Let's look at each of them in details. Nitric acid is a strong monoprotic acid, completely ionized into hydronium and nitrate ions in the aqueous solution. It turns the litmus paper red due to its acidity. It reacts with other metal oxides to form salt and water. It reacts with bases to form salt and water. It reacts with salt to form another nitrate salt and a weaker acid. In the case of acid rain, the abundance of H+ ion in the rain reacts with metals and their oxides that are commonly used to build infrastructure such as buildings and statues, corroding and destroying the structure. In terms of oxidation, nitric acid is a powerful oxidizing agent, one that acts as electron acceptor in oxidation reduction reactions. Make a guess. Which are the determining factors that affect the product of the oxidation of nitric acid? There are three of them: concentration of acid, reducing agents, and temperature. First factor, concentration of acid. Let's watch a video. Pay attention to the color of this solution. From the video, we've seen a blue solution and a dark brown gas released. The solution is copper nitrate and the gas is nitrogen dioxide. So, we can conclude that when copper reacts with concentrated nitric acid, the reaction produces copper nitrate and nitrogen dioxide. The solution in the video is concentrated nitric acid. However, if that solution is more diluted, what we get is not the nitrogen dioxide gas, but nitrogen monoxide gas. The second factor is reducing agents. When nitric acid reacts with different metals, it gives different products of nitrogen, depending on the reactivity of the metal. As we go across the metal chart at the top of this slide, the reactivity of the metal decreases. The higher the reactivity, the smaller the oxidation number of the nitrogen product. For example, if nitric acid reacts with weak reducing metals like iron, copper, it produces nitrogen dioxide and nitrogen monoxide. On the other hand, let nitric acid reacts with strong reducing metals like aluminum, zinc, or magnesium, we get dinitrogen oxide, nitrogen gas, and ammonium nitrate. The third factor, temperature. Some metals such as iron or aluminum are passive in concentrated nitric acid at room temperature. Action of concentrated nitric acid render aluminum, iron passive because the action of acid corresponding oxides are formed. These oxides stops or renders further attack of the nitric acid. Other than metal, nitric acid also oxidizes nonmetals and reducing substances. This takes the oxidation state of this reducing agent to the highest. For example, in the reaction on the left, sulfur is oxidized to sulfuric acid, in which the oxidation number of sulfur is +6. Likewise, on the right, we have iron +2 before the reaction and iron +3 after the reaction with nitric acid. Now, let's put the knowledge that you've learned into practice. Let's discover the usage of nitric acid and how we can prepare it. Nitric acid is widely used in the production of fertilizers, such as ammonium nitrate. Let's watch a video. Now, let's put the knowledge that you've learned into practice. We can prepare nitric acid both in the lab and on a commercial scale. Nitric acid is usually prepared by heating potassium nitrate with concentrated sulfuric acid. This heating is done in a glass retort and vapors of nitric acid are condensed in a receiver, which is cooled by water. The reaction can be seen on this slide. Industrial preparation. On a commercial scale, nitric acid is manufactured through the Oswald's process, the process of catalytic oxidation of ammonia. There are 3 steps in this process. Watch the following video and note down the 3 steps.
About 60 million tons of nitric acid are made each year worldwide. Most is used to produce ammonium nitrate fertilizer. Ammonium nitrate is also used in explosives. Nitric acid is used in the making of nylon and for polymers that are used in sports clothing and swimwear. The raw materials for making nitric acid are ammonia and air. In the converter, nitrogen monoxide is formed. This is cooled and reacts with more air to produce a mixture of nitrogen dioxide and dinitrogen tetroxide. These gases are absorbed in water to produce nitric acid. In this plant, liquid ammonia is fed to the evaporator here. Ammonia is mixed with air here and passes to the converter. This is the absorber. Liquid ammonia is fed directly from the ammonia plant, which is close by on the same site. It is evaporated in this vessel using heat from the hot water produced later in the process. Air, the second raw material, is drawn from the atmosphere and compressed to a pressure of about 5 atmospheres. Filters are used to remove oil and dust from the air, which could poison the catalyst used later. The streams of air and ammonia are mixed here and passed to the converter, also called the burner. This is just the top of the ammonia burner. Inside the burner, the gases produce heat as they react to form nitrogen monoxide and steam. The reaction is catalyzed by a gauze of platinum and rhodium. Catalyst gauzes are changed every 3 to 4 months. The woven metals become poisoned and are returned to the manufacturer to be recycled. The reaction in the converter produces heat. The gas stream leaving the converter is cooled by water. This produces steam, which is used to drive a generator. In the gas stream, the nitrogen monoxide is oxidized by excess oxygen to a mixture of nitrogen dioxide and dinitrogen tetroxide. The mixture passes to the base of the absorption tower. The gases rise up the tower and through a series of slotted trays. Water runs down the tower. A reaction occurs to produce an approximately 69% solution of nitric acid. This is the equation for the reaction. The reaction is exothermic. It produces heat. The blue pipes contain water that is used to cool the acid stream in the tower. The production process is monitored and controlled remotely from a control room. Most customers require the 60% or 69% acid. About half the nitric acid is used on site and half transported by tanker.
I hope you got your steps written down. Let's put them into good use, shall we? Answer the following questions. I hope the past 15 minutes have been enriching. Thanks for watching and see you in the next few lessons.